For today's exercise, I am doing 3D printing in France. 3D printing is known as additive manufacturing. It's a process where physical 3D objects are produced from a digital model through a computer aided design. In the CAD, a series of layers is built one by one for the 3D objects in accordance with instructions provided by a G-code file originating from the licensed software that processed the digital model. In order to create a tangible 3D object, the printer must use materials such as plastic, metallic powders, resin, polymers, or ceramics. In France, you have customers from the everyday citizen at the local library or school to large corporations in bigger cities using 3D printing across varying industries and sectors. For example, in construction, automotive, and manufacturing, 3D printers are used to create prototypes, vehicle interiors, and designs for buildings. Some of the biggest key players are Peugeot, Michelin, Extreme, and Adobe. In luxury retail, companies such as Louis Vuitton, Chanel, Dior, and Cartier use 3D printing to create digital 3D designs for what eventually become new pieces of jewelry, trendy clothes, luxurious cosmetics, and perfumes. French companies use 3D printing for efficiency, productivity, and sustainable and environmentally friendly purposes. These 3D designs can be used for applications supporting their target customers and end users. In many sectors, prototypes and research and development help drive innovation. Additionally, the French government actively supports and funds programs and initiatives that encourage 3D printing. One drawback is that the raw materials can be expensive. So these materials are pretty much costly and they hinder progress based on those prices. Companies who specialize in 3D printing are often struggling to find qualified workers. So think of talented workers, a shrinking talent pool of some sorts. And they endure slow production speeds and mediocre 3D results as a consequence. In France, you have sectors such as automotive and manufacturing, aerospace, and defense experiencing significant market growth due to the extensive use of 3D printing. The industry is also expanding into food, pharmaceutical, and consumer electronics as 3D prototypes and final products open up new revenue streams and increase income. 3D printing has also led to job creation, new career opportunities, and the possibility of Industry 4.0 integration involving technologies like AI, IoT, and 5G. 3D printing also comes with regulations that intensely slow down adoption and technological limitations. To add insult to injury, you have supply chain disruptions, global competition, and economic uncertainty impacting the French 3D printing industry. In France and around the globe, 3D printing is used across varying sectors such as automotive, aerospace, healthcare, luxury retail, metal and plastic research, nuclear, and defense. Specifically within France, companies such as Airbus and Framatome have specialized in 3D printing in cities like Toulouse, Paris, Lyon, Bordeaux, Nice, and Marseille. Since 2008, companies and organizations have used the first global 3D printing center in Lyon as a hub for innovative metal and plastic research. Today, students, researchers, and companies are using 3D printing in markets that are seeing significant growth in this form of technology, especially in aerospace for complex and lightweight parts like aircraft and rockets, in design, art, and fashion for sculptures, footwear, and jewelry, healthcare for 3D designs of organ implants and prosthetics, and education for fossils, 3D geographic maps, and chemistry, biology, and environmental models. The massive nationwide future adoption of 3D printing in France is expected to see significant market growth. I can expect the market value to reach between 5 and 5.3 billion dollars by 2035. Some barriers include costs for equipment and operation, regulations, lack of expertise, and limited resources. 3D printing has helped France and its economy by reducing unsustainable waste, shifting consumption patterns to more responsible and environmentally friendly practices, and improving the people's health by promoting telemedicine to cure diseases, food to provide nutrition from food safe printers, and organ implants to reverse damage. These are the following sustainable development goals that 3D printing achieves. Zero hunger, that's goal 2. Goal 3 is good health and well being. Goal 6, clean water and sanitation. Goal 8, decent work and economic growth. Goal 9, industry, innovation, and infrastructure. Goal 11, sustainable cities and communities. Goal 12, responsible consumption and production. And Goal 13, climate action. These were all discussed in the earlier slides. Now on to the icebreaker. 2 truths, 1 lie. French companies use 3D printing for efficiency purposes, productivity, and sustainability in 3D designs created for their customers and end users. 3D printing achieves Sustainable Development Goal 3 by promoting telemedicine to cure diseases and reversing damage by designing organ implants so French doctors can improve their patients' health. And of course, you have statement number 3. Since 1994, companies and organizations have used the Lyon 3D Printing Center as a hub for weather model research created from digital designs. Which of these 3 statements is a lie?